Welcome back. Today we're doing a deep dive into something truly groundbreaking in science.
ER.
The 2024 Nobel Prize in Chemistry. It went to the developers of AlphaFold.
That's right, an AI system. And it's giving us this almost entirely new view of how life works at a fundamental level.
A new view. How so?
Well, AlphaFold, it's achieved something quite remarkable. It predicts the 3D structure, the shape of proteins.
Okay.
And with, incredible speed and accuracy, it's unlike anything we had before.
Well, put that in perspective for us. What was it like before?
Oh, it was painstaking. Years. Researchers might spend years, sometimes their whole careers, figuring out the structure of just one protein.
Wow.
AlphaFold's predicted structures for, get this, over 200 million proteins.
200 million. That's staggering. The difference is just night and day.
Completely.
So our goal today is really to understand why this is such a game changer, and also to look at the vision of Demis Hassabis, who's really a key figure behind it all. We're drawing on a recent article discussing him and the future of AI.
Okay, good plan. So maybe let's start with the basics. Proteins. Why does their shape matter so much?
Right, yeah. What are they actually doing?
Think of them as tiny microscopic machines or workhorses inside our bodies. They do almost everything.
Everything, like what?
Carrying oxygen, building tissues, fighting infections, countless jobs. And their 3D shape is absolutely key.
How so?
Because the shape dictates exactly how they work, what they connect to, what they do. Its function follows form, basically.
And figuring out that form, that shape, was the big challenge.
Exactly. That was the protein folding problem.
Mm-hmm.
You have this long chain, and predicting how it folds up into its specific functional shape,
Yep.
computationally, it was incredibly hard.
Until AlphaFold.
Until AlphaFold, it got incredibly good at predicting that final structure for, well, pretty much all the proteins we know about.
Which explains the Nobel Prize. From
Yes.
David Baker, John Jumper, and Demis Hassabis.
Absolutely well-deserved. It just opened up biology.
So let's talk impact. With this new power to sort of see these tiny machines, what does it mean for medical research, drug discovery?
Oh, it's transformative. Really. Knowing a protein structure, it just unlocks so much, especially for understanding diseases.
And you give an example.
Sure. Think about diseases like malaria or cancer, even Alzheimer's. AlphaFold provides detailed maps of the proteins involved.
Maps, like blueprints.
Exactly. Blueprints that scientists can use to see exactly where a drug might need to attach or, interfere with the disease process. It helps identify very precise targets.
So it speeds things up.
Massively. It accelerates those crucial early stages of drug discovery. Designing molecules, testing ideas computationally. It's like we suddenly got the instruction manual for a machine that was a black box before.
That's a great analogy.
But it's important to add, right, this speeds up the start of the process. You still need the rigorous clinical trials, regulatory approvals, all of that. That hasn't changed.
Of course, yeah. Safety first. Now, let's turn to the person, Demis Hassabis. He spearheaded a lot of this. His background is fascinating. Chess prodigy, video games, then neuroscience, computer science.
Yeah, quite the mix.
How does that all connect to creating something like AlphaFold?
Well, it seems like that diverse background gave him a really unique way of thinking about complex problems. Chess, strategy, video games, maybe designing intelligent systems within rules.
Okay, I can see that.
And then his deep interest in neuroscience and AI, it all kind of came together at Google DeepMind, the company he co-founded. He was pursuing this fundamental quest to understand intelligence itself, both biological and artificial.
And AlphaFold isn't the end game for him, is it? There's this other project, Gemini.
No. Definitely not the end. AlphaFold was huge, massive milestone, but Hassabis is looking much further. Gemini, it's broader. These are multimodal models. They can understand and work with different kinds of information, images, sound, text, code, and they have more advanced reasoning capabilities. They can even potentially take actions in digital spaces.
Wow. Okay. And that leads to some pretty big predictions. Hassabis thinks we might see AGI, artificial general intelligence, like human-level AI, maybe within 5, 10 years?
That's his prediction, yes. And it's definitely sparking a lot of debate.
I bet, which must raise huge ethical questions.
Absolutely. And Hassabis himself is quite vocal about this. He stresses the need for caution, for focusing on AI safety, ethics, making sure these powerful systems align with human values.
So he's worried about the risks.
He seems to be, yeah, particularly the risks of a global race where safety might get sidelined. He's actually calling for international cooperation, for careful regulation.
Interesting. He also admits current AI still has limits, right?
Yeah.
Like no real curiosity, imagination.
Yes, he acknowledges that. But what's really interesting is he doesn't necessarily see those as permanent limitations. He sort of envisions AI evolving to the point where it doesn't just solve the problems we give it, but it could actually start formulating new scientific questions, questions we haven't even thought of.
That's a mind-blowing idea, AI setting the research agenda.
Right. He sees AI fundamentally as a tool, maybe the ultimate tool, for exploring the biggest questions about life, the universe. And he emphasizes we need everyone involved, philosophers, ethicists, scientists, figuring this out together.
Collaboration is key.
And the potential upside is huge, tackling disease, scarcity. But, as he says, the future depends very much on the choices we're making right now.
So, wrapping this up then, the key takeaway. AlphaFold is this revolutionary tool, already changing biology, and its creator sees an even bigger AI transformation coming.
Exactly. Which leaves us with a thought, perhaps for you, the listener. Beyond solving today's problems, what if AI starts defining tomorrow's questions? What does that future look like, and how do we ensure our own curiosity, our ethics, guide us there?